Question number 36. Which of the following statements are correct with regard to CFC, HCFC and HFC? Right. CFC is chlorofluorocarbon. Chlorofluorocarbon, which means compounds containing 1 to 3 carbons with chlorine and fluorine. 1 to 3 carbons with chlorine and fluorine. HCFC, sorry about this, HCFCs is hydrochlorofluorocarbon. Hydrochlorofluorocarbon. That means again 1 to 3 carbons with hydrogen, chlorine and fluorine. HFCs is hydrofluorocarbon. It's 1 to 3 carbons with hydrogen and fluorine. There are no chlorines there. Alright, let's go to the statement A. Both classes of compounds, CFC and HCFC, have the ability to produce chlorine-free radicals in the upper atmosphere or the stratosphere. Yes, that is true because they contain chlorine. Now, these compounds are harmless in the breathing level, but when they reach the upper atmosphere, they get photolyzed. Photolyzed means the light radiation initiated decomposition takes place. So these molecules form chlorine free radicals. Both CFC and HCFC can produce chlorine free radicals in the upper atmosphere. That is true. This is the chlorine free radical. Now this is chlorine free radical. This happens due to the presence of sunlight. Right, therefore statement A is correct. B statement, both classes of compounds HFC and HCFC have the ability to produce chlorine free radicals. Now this is wrong because HFCs do not contain chlorine. It contains only hydrogen and fluorine. Statement C, all three classes of compounds CFC, HCFC and HFC are strong greenhouse gases. That is correct. These gases can absorb IR radiation significantly than carbon dioxide. So their global warming potential, it is called GWP value, will be higher. Now, chlorofluorocarbon, CFCs are the main class of compounds that destroys the ozone layer. That is due to the releasing of lots of free radicals into the stratosphere. Now HCFCs, they have carbon hydrogen bond. These HCFCs and HFCs have carbon hydrogen bond which is less stable. Now because of the presence of this CH bond, HCFCs and HFCs are destroyed in the lower atmosphere, that means in the troposphere. Now this is the Earth's surface. The first layer of atmosphere is troposphere. The second layer of atmosphere is stratosphere. The ozone layer is in the stratosphere. Ozone layer will be located somewhere around here. The distance will be 18 kilometers roughly from the ground level. So this is called the lower atmosphere. This is called the upper atmosphere. So the CH bond containing compounds like HCFCs, HFCs and HCFCs. They are less stable in the atmosphere, in the upper atmosphere, because in the lower atmosphere these will be destroyed by hydroxy radicals. There are hydroxide radicals in the lower atmosphere, that means in the troposphere. So these oxidize these compounds, these two compounds. Therefore, their residence time in the atmosphere will be far less. Most of the time they don't reach the upper stratosphere or the upper atmosphere. Maybe a small amount of molecules will be reaching the upper atmosphere, but they release a very very lesser amount of chlorine free radicals. Now this doesn't contain chlorine radicals, therefore it does not affect the ozone layer or ozone layer depletion. But HCFC has a far less significant effect on the ozone layer depletion, because most of these molecules are destroyed in the lower atmosphere, so only few amount will be reaching the upper atmosphere, and the ones which reaches the upper atmosphere will release a little amount of chlorine, so it will destroy a little amount of ozone. But the CFC molecule destruction will be far more significant than these two classes of compounds. And the other thing is, now earlier people thought that HFCs do not destroy the ozone layer, but it is wrong. There's a very small effect on the ozone layer depletion by the HFCs. It is mainly due to the global warming potential, because these gases can increase the temperature of the upper atmosphere. The ozone destruction or the depletion reactions get faster at high temperatures. That's how these gases have a higher significant effect on the ozone layer depletion with respect to the chlorine free radical destruction of ozone. I hope you can understand that. So the statement D, all three classes of compounds contribute significantly to ozone layer depletion. Actually only CFC contributes significantly. Its significance will be 400 times greater than HCFC and HFCs. So that means only CFC has a significant contribution. HCFCs and HFCs are contributing to the ozone layer depletion, but in a less significant way, mainly by increasing the temperature and thus by increasing the rate of the ozone depletion reactions. That's all. So there are two statements that are correct, A and C. So the answer will be fifth one. Let's move on to the next question.